Okay. So there's the first one. Right, so, yeah, can you find an easier way to do this? Yeah, it's telling us that all the sides are the same thickness, right, of given thickness. And so we know that the smaller the surface area, the smaller the weight's gonna be, right? So this ends up being, in this case, surface area is just a proxy for weight. You're not gonna, and it does, all it asks for are dimensions. It doesn't ask for what the weight is. So you don't have to do any complicated density calculations or anything, right? That's all you gotta do, okay? Right, and that's just like we did a problem like that. I think our first example we did in class was that exact problem then. Okay, and then this guy. Let's just spend a second talking about how you make a good drawing for these. We can do that part together. Okay, so a problem like this, right? They tell us two sides of a triangle are 16 and 5. Find the size of the angle theta in radians formed by the sides that will maximize the area of a triangle. Well, think, now what's the area of a triangle? What's our formula for area of a triangle? Say it again?
1/2 base height.
Half base times height, right? So if we know that we're going to be doing that, if area equals 1/2 times base times height, think ahead like that just a little bit. Think about what is the quantity we're trying to maximize or minimize. Then when you draw the picture, right, and this is a picture's huge here, wouldn't you want to set it up so you've got, like I've got a base that's going to be sitting horizontally, so it's easy to calculate the base, right? It's going to be 16. And then I've got some other side that's length 5, and that's theta. Well, all I really need here then is just, I don't know what theta is, but I just need the height of the triangle, right? And so if the height of the triangle is going to be related to theta in some way, isn't it? Right? Well, look at this triangle we get out of this stuff. Right? If I look at that green triangle, if that's theta and that's h and that's 5, pretty easy to come up with an expression for height in terms of theta, right? Just a little trig relationship. Okay? That make sense? Yeah. So it's pretty simple to get this set up, right? And then if you want to, you're going to be able to write area then as a function of theta, because you know area is going to equal 1/2 times 16 times the height, which we'll be able to write in terms of theta. Theta is your variable. What would the domain be for theta here, obviously? If I look at this triangle, theta could squeeze down to, what would be the smallest we'd consider? 0, biggest? Okay, so 180 or pi, right? Probably we're looking at in terms of, doesn't matter, either way. You can think of it as degrees if you wanted, right? It's going to go from 0 to 180 degrees, or it's going to go from 0 to pi radians, either way, okay? And there's that assignment. Okay, if I pull up the next one, so those hints ought to help a little bit, I think. And that first one does not take very long. I mean, it really, how long did you spend on it last night? Yeah, I mean, it's like a 10 or 15-minute assignment.
Can I have part two of the paper pencil test?
You can.
You would calculate that, right?
No. Okay, very quick, pause what you're doing, you do the test, and just pause what you're doing, take a quick look at these two. These are the two problems from the next assignment. They're very, very short. So this first one, this is the kind you like because they give you the whole function, right? It says the height of a projectile launched vertically is given by this function, right? So you have height is s as a function of time is negative 16t squared plus 48t plus 36. Well, what's the only thing you need to know? If t is time, what's really the one thing about the domain you probably need to know? Can't be negative, right? So we're just it's gonna be values bigger than 0. Is there an obvious upper limit? No. I mean, eventually the things, you're launching it upwards, it's gonna come back down, right? So there is probably, I guess, after we do the problem, we could go back and say, well, when it hits the ground, I guess maybe it's over with. But you don't even really need an upper limit. You're gonna find the positive value when the height is gonna be the biggest. You're throwing some up in the air, it's gonna get to its apex, it's gonna come back down. That's pretty simple, right? It's already set up as a function of a single variable. So we're gonna, if we do, one thing I'll remind you about, if this is position, how do you find velocity? Remember, it's been a while since we talked about this. Yeah, velocity is gonna equal fs prime, right? Which is easy, I mean, this is a polynomial, it's easy to do. So just negative 32t plus 48, right? And we could calculate acceleration, but we don't really need it. This is just, s prime here is really all we care about. I mean, but it ends up being velocity. Well, we want to find, it says find the object's velocity at t equals 3. We want to find its maximum height and when it occurs. Here's kind of the trick on this one. When would the maximum height occur? When its velocity is 0, which is what we get from doing tables anyway, but doesn't that make sense, right? If the velocity is 0, we're going to get that critical number we'd always find anyway. But in this case, it makes pretty obvious sense what that's going to be. The velocity is going to be 0 in this context. When the thing comes to its highest point, velocity becomes 0, and then the velocity is going to turn around and go the other direction, right? So the sign's going to change to the velocity, okay? So there's that one, very quick. Here's the other one from the second, or from the assignment for Wednesday, I guess. So Hunter's at a point along a riverbank. He wants to get to his cabin located 4 miles north and 10 miles west. Here's the key. So here's the Hunter, here's his cabin, right? He's walking along this stream. Okay? He can travel 5 miles per hour along the river, but only 2 miles per hour on the rocky land, right? How far upriver should he go in order to reach the cabin in minimum time? Well, here's kind of the hint I'll give you on this one. So velocity equals distance over time. So if we solve that for t, t is just going to equal distance divided by speed or velocity, right? So you could break this into parts. You've got the part, we call it t sub r, or the time along the river is just going to equal the distance he travels along the river divided by v, which is, in this case, is 5 miles per hour along the river. The time that he travels across the land is going to equal the distance across the land divided by 2. Speed is only 2, right? So what you'd have to do is you'd have to figure out, well, what are those quantities, right? In terms of stuff up here. Now, the question asks how far upriver should he go? So maybe you call that like x, right? And if that's x, then you have to figure out what this distance is. in terms of x, but you can do that, right? If that's x, then that distance right there is 10 minus x, and that's 4. And by Pythagorean theorem, you can figure out what that quantity is, right? To get those distances. Okay? All right. Give you a little hint. Okay. You may work.